Haven't seen Yachty in forever. What's up, Yachty? There we go. That's up. Nice. Yeah, we're gonna do. Let's see. We're gonna do a special giveaway today because I was out Friday and Thursday because my sister graduated law school. I had to go up to Chicago, go celebrate that. Not the biggest fan of graduations, but it's okay. Let's go live. 1 second. Let me go live on TikTok first, real quick. Okay. Play nice, TikTok. Not today. Education, good. Alright, we're live on that. Cool. Cool, 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 cool. I saw the new Guardians of the Galaxy. Ooh, that's cool, Zach. How was it? Episode 3, right? We're up to... It's the third one? There's like a trilogy that's out? Yeah, it was great. That's sick, dude.
That's dope.
That's sick. Are they going to make a fourth one? Did they set it up in that way? I feel like it's such a great franchise that they can't really ever stop making those movies. It's kind of like the Avengers with Marvel. They just keep putting out more and more films. I think if you look at it, there's a whole thing here. Let me find it. There we go. What is it? It's the Marvel movies in order. Like, they made so many of these movies. There we go. This is apparently the order you're supposed to watch them in or something. Oh, they did leave it off in a cliffhanger. Oh, that's cool. Nice. Very cool. Very cool. Yeah. Yeah, I guess although I think Iron Man was the first one that actually came up. Yeah. So it was this, and then oh wait, is my mic already screwed up again? Windows, you dumb. 1 second. Let me fix that. Are you oh, Macbeth, that's cool. Yeah, there you go. Fixed it. All right, cool. Mic's fixed. Oh, sweet, Macbeth. That's cool. Yeah, so here's Guardians of the Galaxy Volume 2. And then I guess Guardians of the Galaxy Volume 3 must be somewhere in here then. Must be the next place for it. Anyways. I'm not the hugest superheroes movie buff. But they're cool. Zach, what's your favorite? Which one's your favorite? Out of Marvel. Even DC. I heard the DC movies are kind of these days, but... Age of Ultron. Ooh, that's cool. That's not Endgame, right? That's the one before Endgame in terms of the big Avengers films. Yeah, I think so. Cool. All right, cool. Let's start off office hours. It's been like 5 minutes. We're good. All right. Welcome, everyone, to office hours. My name is Dr. Gold. This is Actual Education. Stream helps you out with math homework, science homework, all sorts of fun stuff. We have a good time. Yeah, I wasn't here on Friday, but it looks like we had Rampton take over pretty well. He certainly drew a lot of things here. This is cool. Wow. Laplace transforms. Wow. Okay. Oh, he went really into... Okay. Oh, there's a lot here. The Casimir effect. Oh, very cool. All right. Very cool. Yeah. I'm experimenting with this thing now. You know, I can't be around to stream all the time because, life happens. Life gets lifey is what I say, and I got to go do stuff. So I hope this was helpful. It looks like Rampton did some good stuff. Yeah, here, he was explaining fractions to you guys. Okay, cool. Sick. Thanks, Rampton. What's up, Hikaru? You want to come up? Yeah, you can come say hi. What's up, Hikaru?
Well, see that? I mean, that's 100.
Mommy!
Mom's being kind of loud, I guess. I don't know. Yeah. We have a lot of new things too also in the Discord that have been happening. So many new channels. I'll make more of an announcement about stuff. Here, join the stream. But yeah, Habib, thanks, dude, for the newspaper article you wrote for Friday. That was great. I appreciate that. Always looking to have good people. Bonjour, Habib. Yeah, always looking to have good people on the newspaper team writing things. All right, let's see. We got some questions. Again, we're starting to get to the end of the school year, so you may not actually have many questions coming up. But it's always a good time you can go over things that you didn't quite get during your math class during the year. Or if you tell me what grade you're in, I can teach you stuff that you're going to be going into after the summer. And believe me, it helps if you've already kind of done it a little bit beforehand to then like go into the new stuff. It's pretty useful. Oh, someone asked about the ladder again. Yeah, Sokotoa. That's cool. Yeah. Oh, and then someone asked about this. Cool. Okay, cool. Lots of good questions. What's up, Opie? Okay. All right. Let's see who's got the first question up. Teacup does, but Teacup, are you here? Teacup says skip. Me not knowing what any of this is. What's up, LND? Yeah, no, it's so LND. This, and for anyone who's joining us here on TikTok too, this is a stream where you can ask like whatever math or science questions you have, from your class. So if you're going through something in say algebra or pre-calc that you didn't really understand, it's a great time for you to just post that and I'll teach it to you so it makes sense. And what that does is that helps out other people that are watching kind of on the sidelines because they also get, a little bit of an education with it. Yeah, that's what it is. That's what the stream is. So let's go to the first question we got. I don't think Teacup is here. But okay, we'll do OP Blacks. OP. Let me see where it is. Boo, 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 boo. If X, Y, and Z are factors of this. Oh, that's a cool one. I like that. That's a good one. This is another good one. Algebra. We're doing some algebra. I like this. Okay, cool. What's up, Sonic Skull? How's it going, bro? Oh, what's on the board? Oh, yeah. Don't worry about this. Yeah, no, this stuff here is college level physics, probably. Yeah, this is college level physics or kind of like vector calculus is what this is. Don't worry, this is stuff you do in college. Yeah. This you should know if you're in high school. This is kind of pre-calc is what this is. Pythagorean theorem. This is also Pythagorean theorem. This is kind of early high school, maybe mid-high school. Yeah, that's where this comes from. Okay, cool. OP, where are you at? Are you in the stage? Junior stuff since I'm a sophomore. Yeah, exactly. Yeah. Yeah, it depends. Some maths move faster than others based on what high school you're in. But this is an example one. Okay. Says if X, Y, and Z are three factors of this, then the value of X, Y, and Z will be. Oh, this is a cool one. Okay. So factors are things that you can multiply by that end up equaling this main thing here. Here's an example of one. Let's say that I had yeah, okay. Let's say, for instance, I had x squared minus 5x plus 6. I could factor this out using factoring into two different factors. This could be the same thing as x minus 2 times x minus 3. So in this case, we would say our factors are x is equal to 2 and x is equal to 3. I think it's that. I don't think it's the negative one is what it is. Yeah. And you can see how this works because if we FOIL this back, this is x squared minus 2x minus 3x plus 6. This becomes minus 5x. And you get the same answer, okay? That's what factoring is. Factoring is taking something that's what we call a higher order polynomial, okay? Higher order. Which is just fancy math language for bigger exponents. That's what higher order means. It means bigger exponents. Notice how this has like an exponent of x squared, whereas these things are only like x to the first. So this is taking a higher order polynomial. Poly means many terms. And factoring them into two what we call binomials. These would be binomials. Because I know you guys see these math terms all the time in class. Your teacher's probably saying these things, and you're like, yo, what the hell is that? You know. I'm here to kind of like help like translate what the stuff is. Yeah. Okay. Cool. So that's where that comes from. This is a trinomial, or not trinomial. This is a trinomial, but sorry, this is a third order trinomial because it goes up to a to the third. All right, which means this becomes a little bit trickier. What's up, Teacup?
Yeah, your stream won't load for me. It's probably just me though.
What's wrong with my stream?
It's stuck on loading.
Oh, well, it says I have 8 viewers. Hey, anyone in the Twitch chat, is my stream working?
Nope, there we go. I just messed with it.
My Prime sub didn't resub this month. Yeah, you got to do it. You got to do it manually. Yeah. So the whole thing about the Prime subs is that you have to go in and you have to sub again, and you have to do it manually. Yeah, that's why they make them a Prime sub. Now, did you know there is no fun way to do this? Hey, Gold, what's up, Pug? Good to see you guys. We got a lot of people. Alexandria too in the chat. Cool. Is there no fun way to do this one? Yeah. It says it costs money. I use the free one. See if there's the free one. It depends on whether you have Amazon Prime or not.
How are you doing?
We're factoring this, but Noise says, now, did you know that there's no fun way to do this one? I'm curious. Why is there no fun way to do this one?
Can you ping me when it's my question? I have a math final tomorrow, so.
Okay. All right, your question's next, so I'll ping you, dude. You're good. Alexandra, how was the AP Physics exam? You took AP Physics and AP Calc. Yeah. Is there no fun way to do this one, Noise? I know if this was like a square, this would be not too bad to do, but like this with a cubed, like what do we do here? Oh, did you know there is a fun way to do this one? Ooh. I like fun ways. What's the fun way, Noise? You teach me. You teach the class. What's the fun way to do this one? I'm curious about this a cubed. Is this a... Oh, man. How does this work with cubes? %, rotational motion and simple harmonic motion. Wow, okay. That's a lot. Yeah. Lots of springs, I guess, then, right? Oh, that's super fun. Have I ever heard of Vieta's equations? Oh. 3 of the FRQs were rotational? Oh, geez, that's a lot. No, Noise. I have not heard of Vieta's. Well, let's look it up. One second. Let's go. Vieta's equations. I always love when I learn something today, you know. Oh, very cool. Okay. Vieta's formulas relate the coefficients of a polynomial to the sums and products of its roots. They're named after this. Okay. This is quite advanced if this is for an algebra class. I don't think this is for an algebra class. Oh man, it's all mumbo jumbo. Okay. Okay. I like this though. Oh, I see. Yeah. This is cool. I didn't know this actually. This is a cool one. This is a cool equation. And actually, let's see if this works for the. I'm curious about the other one. What was it? What was it for 2 dimensions? They said this was it for a quadratic. That's pretty cool. I wonder if we can determine what the roots are based on this though. Let's check it. Okay. Because this is what we said for a quadratic. Okay, so in my case, remember let's say the example we had here. We had this, so this is 1x squared minus 5x plus 6, right? In this case, a was equal to 1, b was equal to minus 5, c was equal to 6, and then these are the roots. Remember I said that the roots were 2 and yeah, 2 and 3. So let's see if that makes sense. So if a is minus 5, or a is 1 and b is minus 5, that tells me that root 1 plus root 2 must equal negative 5 over 1. So that's equal to 5. Does that make sense? Yeah, look, root 1 and root 2, 2 plus 3, is equal to 5. That's cool. And then root 1 times root 2 has to be c over a. So this over this. Okay, so 6 over... Oh, this is just the... Oh, man, dude. This is the... Yeah, this is the basic... Oh, this is cool. This is the basic, like, what multiplies to this but adds to this. Ah, very cool. Okay, but there's a different thing for third orders. Okay, cool. All right. What was the thing for third orders? Okay. All right. In the case of a cubic polynomial, remember I was talking to you guys about orders of polynomials? This is like order 3 is what we say. Order 3 means that the biggest exponent is a 3. Okay. Here we have, and let's replace the x's with, the a's with x's. It's just going to look nicer. Okay, so x to the third, and then this is going to be plus 0x squared. Notice how there's no squared term here. Minus 7x minus 6. So in this case, a is equal to 1, b is equal to 0, c is equal to minus 7, d is equal to minus 6. Okay. All right. And they tell me that the roots, so root 1 plus root 2 plus root 3 must be equal to this coefficient divided by this coefficient. Well, in that case, that's 0 over 1. So I say the roots must all add up to 0, which, yeah, that's here. These are the 3 factors. This will be equal to 0. OP, that's what that will be. That's the answer. That's done, is what that is. Okay. But that's not any fun, because, wait, can I determine the other ones? I kind of want to. All right. Okay. So I know that, so let's just call the roots, so R1 plus R2 plus R3 must be equal to 0. I kind of like that. That's cool. All of them multiplied together must be this one divided by the negative this one. Okay. So R1 times R2 times R3 must be equal to negative 6 over 1. So it must equal to 6. Okay, very cool. So I need all the roots multiplied together to equal to 6. There's only so many numbers that if you multiply them together you get 6, right? What's that? Like 2 times 3 times 1, right? Oh, this is so cool. Noise, this is so cool, right? Yeah. This is a fun question. Yeah, okay. So I know the roots could either be, the roots need to be 2, 3, and 1, but I need them all to add up to 0. So I could either have minus 2, minus 1, and positive 3, or it could be positive 2, positive 1, negative 3. Reason for this, right? You see how all 3 of these add up to 0? Minus 2 minus 1 is minus 3, plus 3 is 0. Same thing here. 2 plus 1 minus 3 is 0. And then all 3 of these numbers multiply to positive 6. Or actually, no. Only this one multiplies to positive 6. Okay. This must be the answer then, because this multiplies to negative 6. Okay. Cool. I think we found our answer then. Okay. And here, we can check this. So let's see if it's, so that's a plus 2 times a plus 1 times a minus 3. Let's see if that foils out to what our original thing was. I'm just getting back from East Coast time, so I don't really want to do all these. I'm just going to have Wolfram do it. Let's see what that comes out to be. I'm curious. Yeah, that's a to the third minus 7a minus 6. Is that what we had? Minus 7a minus 6. Cool. Okay. So yeah, this is your final answer. Nice. Very cool. Oh, go Flappy. Noise. Yeah, that's cool. I like that. That was very cool noise. I didn't know about those Vieta equations. That's cool. So, yeah. I guess that's where this whole when we learn to factor just quadratics, the multiplies to this, adds up to this, there is similar equations for higher order ones, such as third order. That's very cool. Yeah, I thought it was dope. All right, nice. Okay, cool. Good question, OP. I'll give you bond coin for that one. Even though you weren't here, OP. Where is OP? you gotta be here for your questions. Okay, cool. Let's see what else we got. Okay, Sonic's got a question. I like this. This is a good question. This is a trig question. Very good question with trig. Yes, I just saw it. I saw it. Nice. I'll go do it. Yeah, that's a fun one. That looks cool. All right, Sonic, where you at? You in the chat? Are you in the Twitch? Where's Sonic?
Well, said I don't exist.
Oh, you are here. Oh, thanks, Habibs. Seeb is gifting. You've gifted four subs on our channel, dude. I appreciate that. Thanks.
Comment W Habib.
Comment W Habib, dude.
You should do my.
Yeah, let me do your question. Let me do your question while we wait for Sonic to show up. Yeah,
I'm gonna ping him.
I already pinged him. It's okay. Here.
Oh.
Let's see.
Yo, I hear there's an 800 Robux giveaway.
There is. Yeah, I'm gonna give out 800 Robux today, because just because I'm being awesome today.
Note, I won a few spinning wheels today,
so maybe you'll win the spinning wheel today.
Yeah.
Yeah. Okay. All good. All right. Do we know how to simplify this radical, Teacup? Oh, Pug got the baby voice on. I love the baby voice.
See, that's my issue. I learned how to do it, but then I'm not good at doing it. So
okay.
I need help.
That's all right. That's all right, dude. So first thing you should notice is anytime you have a square root of fraction, you can write this as the square root of two fractions. I can write this as 867 over the square root of 169. Okay?
W.
Do you know what the square root of 169 is? This should be a special one that you should recognize.
Alright. Isn't that like 13?
Yes. This is the same thing as the square root of 13 squared. Yeah, 13 squared is 169.
I had to use my inner brain.
Yeah, good job, dude. So that's 867 over 13.
A long time.
Yeah. Okay. 867 looks messy. Really don't want to deal with that. So let's try to factor it. Okay. Let's try to figure out the factors of 867. Maybe we'll come up with something nice. So it's obviously not going to have a factor that is 2, because you see how this is odd, right? So it's not even. Maybe we can pull a 3 out of it, right? So this is where, I mean, we could do long division. I don't want to do long division. I feel like that's a waste of time.
We hate long division.
We don't like, well, it's okay. I'm just going to do this divided by 3, just see what happens. Ah, this does work. Okay, cool. So this becomes 3. I knew 3 might be it. Anytime I see 7, I start kind of thinking that 3 is a factor. So that's 3 and 289. Okay. All right. Then 289 can probably be broken up into 3s as well, I'm going to guess. Let's divide that by 3. Oh, no, it can't. Uh-oh.
Oh, no.
Uh-oh, 289 can't be broken up by 3s. Okay. Can it be broken? So probably can't be broken by 5s because it's not 5 or 0. It can't be broken by 4s because then it would be even. 6 also even. So can it be broken by 7? No. Ooh, okay.
What about 11?
Yeah, let's try 11. No 11. Right? We're not trying 10 because 10 is also even. And we wouldn't try 9 because if it was divisible by 3, it would also be divisible by 9. Maybe 13? Now you gotta start thinking of the prime numbers. No, fuck, dude.
17.
17. Oh, it's 17. Oh, I should know this one. Yeah, okay. This is 17 and 17. Okay, cool. All right, yeah. So this is 17 and 17. Okay. What do I do now that I've broken up my factors this way? What do I do next?
Do we times 17 times 17? I don't know.
Okay. Well, so this is the same thing as the square root of 3 times 17 times 17. Right? That's how we could write that, all right?
Can you screenshot on Discord?
Wow, dude, yes. Oh my god, I'm so sorry. You guys gotta tell me. You guys gotta tell me if I'm not screen sharing. Okay. Thank you.
Like I'm trying my best to pay attention, but I can't see.
No,
what
there
you're
we go. Oh
talking.
my God, please, yeah. Sorry, I was wondering why Alexandria was in the Discord but watching on YouTube. That makes total
Wait, on
sense now.
YouTube?
Yeah, I'm streaming on YouTube too. It makes total sense because, yeah, because I wasn't streaming on Discord. It's just so, dude. I start this stream and I got to be like, okay, stream on TikTok, stream on YouTube, stream on Twitch, stream on Discord, and like I'll
Stream
forget.
on Crunchyroll.
Yeah, I'll stream on Crunchyroll, dude. Yeah, I'll forget one eventually. Okay. All right. There you go. Okay, now we're streaming on Discord. Yeah, my bad. Okay. Oh, Sonic's here too. Cool. All right, Sonic, we're gonna do your question next. All right. When I have something like this teacup, all right, do you know how I can simplify that? Let's say, for instance, I had the square root of 2 times 2. What would that be equal to?
4.
Well, the square root of 4, which is just equal to 2. Yeah. Do you see how this is just the square root of 2 squared?
Yeah.
Right? You're just trying to find pairs. Okay, let's say it was the square root of 2.
Would this be 3 times 17 squared?
3 times 17 squared. Good. Yes, that's how I could write
This
this.
square goes away, so that would be 17 square root 3.
Good. Yes. I can also write this as the square root of 3 times the square root of 17 squared. The square root of 17 squared, that goes away. It's just 17. So we get 17 square root of 3. That's what that is. Okay? So, instead of writing this, right, I'm going to write this as 17 square root of 3 all over 13. Okay? And that's it. You're done. Nice. Yeah.
So I don't mean to be a bother, but the
You're good,
questions
dude.
that are going to be on my final,
Yeah?
they're going to be similar to this, but they're going to have variables.
Okay. Can you get an
Yeah,
example of
think
one?
about that.
Can you pull up an example of one?
Let's see.
If you show an example one, I can help you with it. Let's do Sonic's question. Where's Sonic? Sonic, come to the stage.
I'm gonna fail my.
No, you're not, dog. Chill out, dude. What's up, Sonic?
I'm actually gonna owe them points. That's how bad I do.
Hi. Hi, Sonic. Do you need help with this one? Is that Ronaldo? Is that his profile? Is his profile picture of Ronaldo? Is that Ronaldo? Apparently there was. I don't think I talked about because my parents are working. Oh, it is Ronaldo. That's cool. Yeah, one sec. Let me. Hikaru wants to say something. Hikaru, come on.
Why in English?
And then after we do Sonic's question, I'm gonna do the Robux giveaway. So maybe
That's it.
You promised my son free Robux?
you promised my son free Robux.
Free
Dude,
Robux.
I have had some parents be like, "Yo, who the hell are you? This guy giving my kid Robux?" And I'm just like, "Okay, I'm just trying to help your kid with math. It's okay." Forget who. Someone. It was someone's dad was like an executive at IBM and was like harassing me for like proof. And I showed everything. I showed my IRS documents. I showed so many things. And the parent was.
Did you show your passport, your ID, your credit card?
I didn't. I didn't go that far. I didn't go that far. I said, here's my IRS documents. You can look it up. My name is this. And he says, how do I know it's actually you? And I said, oh, well, you can watch my stream. It's literally me.
Should have showed the passport.
It's literally me.
Should have showed the credit card.
I should show the credit card. Okay. All right. Here, so let me ping the Roblox gamers. 800 Robux giveaway in the next, let's say 10 minutes. Just hop on the Twitch or Discord stream.
That's not good. I can't find anything.
Eligible. Okay, cool. All right. There we go. We're going to do the next 10 minutes. All right. Sonic. All right. Find all angles in the interval 0 to 2 pi that satisfy the expression. This? Is that what they're saying? They want to know this? That's kind of cool. Okay. Cosecant is equal to this. So it's actually kind of important to know what cosecant is.
Have a good day, Gord.
Have a good day, Tika. Oh, yeah, post an example of what your test question will be with the variables, and I'll show you what it is.
I couldn't find
Okay, well, I'll find one for you. So just come back at some point.
Okay, I'll be back in like 10 minutes so I can be here for that giveaway. I'm still going to be in the Twitch. But...
Yeah, as long as you're just in one of the things. It'll be in around the next 10 minutes. I don't know exactly when it'll be. Once we finish Sonic's question. You too, thank you. Okay, so... Cosecant is the same thing as 1 over sine, Sonic. Did you know this? kind of a good refresher if you don't. Yes. Okay. Perfect. Okay. So let's remember that sine. So they they give you these as like hints, which is nice. That's nice of them to do that. Because you can see here, right? Sine of theta is equal to. Oh, we want to find the angle. Okay. I got you. Well, look at this. So if we have 1 over, let's say, the square root of 3 over 2, this is the same thing as 2 over the square root of 3, which if I multiply by square root of 3 over square root of 3, this becomes 2 square root of 3 over the square root of 3 squared. Squareds go away with square roots, so this just becomes over 3. Okay. What does this D and R mean, though? What does this D and R mean, Sonic? What are we talking about, the D's and R's here? I'm trying to figure that out. Because this is also missing a minus sign now. Oh, domain. Oh, okay. Huh. Wait. But the cosecant can't be negative if the sine is positive. That doesn't make any sense. Because sine is, 1 over sine is the cosecant. I would say nothing satisfies this. You can't have anything that has the cosecant being negative, but the sine being positive. Because by definition, cosecant is 1 over sine. I think. Yeah. I didn't know the sine on the left turns into cosecant. Well, you can, right? So I can write 1 over sine, right, is going to be 2 square root of 3 over 3. And that's the same thing as cosecant, is what I would say. But they want to know it. So here, let's ignore this for now, okay? Let's ignore this for now. And we're just going to look at this, okay? All right. Cosecant is equal to negative 2 square root of 3 over 3. Okay. So if I were to do this in terms of trig, right? This is 1 over sine is equal to negative 2 square root of 3 over 3. Let's remember that sine is equal to the opposite over the hypotenuse, okay? So 1 over sine is going to equal the hypotenuse over the opposite, all right? And, okay, so, and what you always kind of want to do, when they look like these nice numbers with 2s, square root of 3s, 1/2s, you want to use stuff where the hypotenuse is equal to 1. That's the unit circle. Here, I'll pull a quick picture of the unit circle for those that want to remember. One sec. Yeah, this thing. Cool. We have a quiz to memorize for our next test. Yeah, I have a very cool way actually to memorize the unit circle without doing, memorizing a gazillion numbers, because like honestly, like this sucks. Like
That's dope.
Well, no, you don't. That's not dope. You don't want to memorize all this. This sucks, right? I have a pretty cool trick for how to do this. I actually, you know what I'll do? I'll send you my TikTok on that. It's pretty cool for how to do these. Okay. All right. If the hypotenuse is 1, I want 1 over something to be equal to negative 2 square root of 3 over 3. Okay. So let's flip that. So something over 1 is equal to 3 over negative 2 square root of 3. If I multiply, let me see if that's right. Yep. If we multiply both.
Hello.
Yo, what's up, Ramton?
How's it going?
Good, dude. Good. Square root of 3. Here, Sonic, if we multiply the top and bottom both by square root of 3, this goes away and just becomes 3. So I get 3 square root of 3 over negative 2 times 3. These things cancel, and so I get negative square root of 3 over 2 is equal to the sine of the angle. That's the main thing, okay? So when they say they want the cosecant of theta is equal to negative 2 square root of 3 over 3, they're really asking where's the sine of that angle equal to square root of negative square root of 3 over 2, right? This you know. This is a very common number you've seen on your unit circle, okay? And there's a couple places that happens, right? So in terms of the unit circle, right? If this is cosine and then this is sine, sine equaling negative square root of 3 over 2 is going to equal that here, right? This angle here. Or it's going to equal it here, this angle right here. Okay? But now we have to ask, like, which one is it going to be? Okay? Well, here's the other important thing here, is they say that the cosine of the same angle has to be negative. Okay? Has to be negative square root of 2 over 2. Cosine of the angle is negative. Okay, wait, this doesn't make any sense at all. What? Because this happens at 45 degrees. This happens at, like, yeah, what is this? This happens at 60. I don't understand what your teacher's saying here with this. Here. I think this is kind of what they want. Yeah, this homework is confusing. You can't hear a thing? What's wrong, Slimy? No, I think my mic's working. Check your audio. Yeah. It's these two. And I'll tell you, I'll show you what I think your teacher wants you to say, okay? So you have two options here, okay? You have one where, let's see, we're here. Okay. And this is going to be, what was this? This was sine. So this is going to be 60 degrees. Or we have this one here, where this is going to be 60 degrees. And what this does is this makes a triangle where if the hypotenuse is 1, the opposite is negative square root of 3 over 2. Negative square root of 3 over 2. And what this total angle really is, okay, from here to here, right, that's going to be equal to 240 degrees. Or in this case, let's go all the way around this way. This one is going to be equal to 300 degrees. And your teacher probably wants them in radians, Sonic. So what you can convert these always, right? If you want to do 240 degrees, just multiply it by pi over 180, right? And that's going to get you 4/3 pi, right? Good. You figure out the radians? Okay, cool. You got it. All right, yeah. 4/3 pi or 5/3 pi. Now, what they can also say is, for instance, they could say, okay, but the cosine of this angle is, for instance, negative 1/2, okay? Which one of these angles has the cosine being negative? The first one or the second one? The 240 or the 300? Because I think that's what they were saying here. They said they want the cosine to be negative. Let's assume she just says the cosine's negative. Or she put the right number. So let's look. If we have this triangle, right? Cosine, right? If this is this side, this is negative 1/2. And if we look at this triangle, this side is positive 1/2. You got it, Sonic. You got it. You got it. Is this the cast method? What's the cast method, Noise? It's cosine. Yeah, but here's a better way. So cosine of theta, right, is adjacent over hypotenuse. Let's look at these two triangles that we've created here, okay? I've created this triangle, right? Do you see how the adjacent here is negative? Because we're on the negative side of the x-axis, right? And then in this triangle, right, the adjacent is positive 1/2 because I'm on the positive side of the x-axis. So which one of these triangles has the cosine being negative? I don't like trig very much. Yeah, trig is cool. Trig isn't so bad once you know that it's just all triangles. Yes. Very good, dude. Very good. It's the left, okay? Yeah, so the left one, right, has cosine b. And you can see this here. Do you see how this is right? This is, what is this? This is cosine sine. See how this one is negative 1/2 and this one's positive 1/2? Right? That has to do with drawing these triangles, is what it is. Yes. Okay, cool. All right. Good job. Yeah, so if she wanted it to be negative, I would just say it's 4 pi over 3. I would say this is the answer. Honestly, yeah, this homework is a little weird. I don't understand this domain range part of the question. Usually they say cosecant of theta is this, and they'll say like cosine is positive or cosine's negative is where that would come from. If you want to know a quick way to learn how to do, because memorizing this is no fun. It sucks. Don't do it. Like I tell all my students, you don't need to memorize this. I'm going to send you, I have a TikTok video. I have a series of TikTok videos I've made on this. Because I could explain it to you again, but it would take another 20 minutes. Where did I do it? Yes. Here we go. This is what I want you to watch. Here's a video I made about how to do the sine and cosine tangent all at these nice angles. It's always like 30 degrees, 45 degrees, 60 degrees, and then it's just like some multiple of it. And it has to do with, like, you only have to memorize 2 triangles. And once you know these 2 triangles, you can figure out everything on the unit circle. You don't have to memorize shit. You just got to memorize 2 triangles. A lot easier than memorizing a gazillion numbers on a unit circle. So there's that's the TikTok for it. Just, yeah, please watch it if you want. Or, you know, it's useful. If you want, because sometimes TikTok's weird with, like, scrolling through stuff and whatnot. Let me get you. You were bald. I'm not bald in this picture. Just my hair's up there somewhere. What? One sec. Let me give you the YouTube links. So that's our TikToks that go through it. Yeah, so katoa. We love it. Yeah, that's it. Or here, let me find. Here's the YouTube. YouTube sometimes is nicer to scroll through because I understand. I talk kind of quick because when I first started making these videos, TikTok had a requirement it couldn't be over 60 seconds. So I had to fit everything in 60-second chunks, which was kind of annoying. Now you can go up to like 10 minutes. But I still try to keep it short because, you know, limited attention span. Okay, cool. All right. Let's do a giveaway. Because I did promise you guys a giveaway. Let's see. Let's give away some Robux. Where's our spinner wheel? Yes, you're very welcome, Sonic. Yeah, come by anytime, dude. I'll help you out, dude. All right, let's see who's here. Who's here for the spinning wheel? Pug says I'm here. Cool. Pug goes in.
Also,
What's up?
just to I guess Friday when we did it, it was Noise, it was
Okay.
Riplaw, and it was OP Black that they were asking questions. And
Cool.
Stuff. Just
Yeah. How'd that go? Someone said it was awesome. They said I got to ask as many questions as I wanted. I was like, oh, that's cool.
Okay. That's good. Yeah, I think Riplaw had like 2 questions, and then
Nice.
OP Black had 2 questions, and then are you on the whiteboard actually? Like you can see.
I did. I saw the whiteboard. I saw you did Laplace transforms. I'm like, whoa. I was like, I need to teach myself this. This would be pretty cool.
Yeah, the Laplace equation, we did the general solution of that. And then that was pretty.
That's cool.
Pretty fun.
Yeah, that's cool. Yeah. No, it was well reviewed. You know, they're well received. I had a couple students message me being like, "Oh, that was cool." I was like, "Sick." Yeah, that's always the goal. Is that, you know, we can have more opportunities for kids to learn, even when like we're not always online all the time, right?
Yeah, that's good.
Yeah, we should get you on OBS eventually is what we should really do. Because then I think that'll really help having the Twitch, because I have like 10 people on Twitch right now. And so if you can broadcast at Twitch, that'll be able to get a lot of other people to get help.
Yeah, I'm gonna figure it out within the next few days, maybe like a little bit today as well.
Yeah.
Because because I don't wanna, I've looked at it, but here's the thing with me is that I don't like to start something if I'm gonna botch it.
So well, let me help you.
Like...
I can help you make it perfect, and we can do like test runs and stuff. Like, don't worry.
Okay.
All right. Let's see. Nobody asked. Who else was in here? Nobody asked. Slimy King. Who else am I missing? OP Black's in here. Teacup. 800 Robux. It's for 800 free Robux. Yes, that's what it was for. And Habib. Habib's in here for sure. What's up? Okay. And then here, because Noise and OP Black asked Ethan. Wow, Jesus, Ethan. Yeah, your mic is very loud. Thank you. Ethan's here. But because OP Black and Noise asked questions during Friday's session, I'm gonna put your name in twice. Because I appreciate that. Cool. So OP, your name is in there twice. Nobody said I asked a question as well. Did you? Did you? Did you ask one on Friday? Let's see. Or you asked a question on today's? Yeah. No. Yeah. You're in for today. You're in for today. Yeah, you're in for today. Yeah, I'm saying for Friday. Some students showed up on Friday's bonus stream when I wasn't here. I was out of town, and I want to give kind of a bonus to those kids who showed up because I appreciate that. Okay, is that everyone? Do I have everyone? Do I have everyone on the spinner? Everyone on the spinner wheel? Tell me if I don't have you on the spinner wheel. I think I do. If you don't see your name, where be me? Oh yeah, Teacup. Did I? Yeah, Teacup. You're in there. You're right here, dude. There you are. But no, thank you. I don't play Robux. It's okay, Noise. You can give it to someone else if you win. I'll let you. You get to play my role of being the Robux fairy. Spin the wheel of faith, he says. Okay, fine. We're spinning. Here we go. Spin, she goes. Who's it gonna go to? Who's getting 800 Robux today? Wow, it's Slimy. Congrats, Slimy. Good job, Slimy. Yeah, Slimy, you won, dude.
That's dope.
Good job, dude. Yeah, nice. Cool. Shifter gay. Chill, Shifter. Shifter, you've won so many other times. I did not expect that. It's okay. There's a 100% chance of something happening. And you had a 1 of 15 chance of winning that. So what percentage is that? Was it like 8%? Or like, what is it, like 6%? 6%. 6 or 7%. Very low chance. 6 or 7% chance. Yeah, that's cool. Yeah, see, Slimy? Bro did the math. And yeah. Okay, cool. All right, let's see. Who else we got for questions? Ooh, I like this one, Nobody. It's a good one. OP Black told me I was a good teacher when it was Rampton who was teaching me on Friday stream. Oh man, that's too funny. I would have actually liked to have. Wait, did anybody? No one was able to record this stream though, right? No one was able to record it. I think I remember.
For like this whole shenanigan.
I would have loved to see this. This is super cool.
Yeah, keep scrolling down. There's like more.
No, I know. I was scrolling down. I'm like, oh, okay, here we go. Oh, and now we're going into the Casimir effect.
Yeah, like I think I don't remember how that came up, but
I'm like watching your stream of consciousness in like writing form, and then eventually we just get to this. A plus B L
yeah,
R.
I think with this one, I forgot to just to add something to this actually, just because what's his face Noise was there.
Yeah.
I'll add something to this in like 30 seconds if you give me.
Yeah, I'll give it to you. You're good.
Yeah.
Here, let me send Slimy his Robux. Good job, Slimy dude. Where did I put it?
Wait, for some reason the link doesn't work anymore.
Oh, really? Should.
Oh, wait, no, it's fine. We're chilling. Okay. Just so that there's a nice record of this also in the thing. Let me add something to this quickly. But yeah, it was fun actually. This took us probably like.
You were on for like 2 hours. You're streaming for like 2 hours.
Yeah, so we streamed for like 2 hours, and then I think about hour 10 minutes of it was like, OP Black and Riplaw.
Mm-hmm.
And then about an hour of it was just this question.
Well, yeah, I can see it was a lot of writing.
Yeah. All right, just to add something, because I think my brain was shutting off.
It does.
After
2 hours, it does shut off.
Yeah. So we talked about if noise in case, especially watching as well. So in here we had the n, r to the n being a solution, and then you can see that if we do this, first of all, you get your n to be the square root of k. So the constant that it is, you could a lot of the times, just because this is an arbitrary constant, you can equate it to minus k squared, like where we have like up here where we equate it to, or say to just k squared instead of k, just so that because it's arbitrary, you can just make it look nice.
Mm-hmm.
So that's the thing. And then the other thing is also the same exact thing here works if we just have r to the minus n, because just minuses come down and then you get the same exact kind of equation, and so that works also. Then the case of ln r, this is something that I wanted to just clarify. This is when if your arbitrary constant is just 0. That's it. But how do I erase something?
You can just select all this and then just delete.
Oh, there we go.
Yeah.
Yeah, so the only thing for this I wanted to, just because Nice is here, if your k equals to 0, then your equation is r squared r double prime plus r prime is equals to 0. You can also drop an r from this,
provided r is not 0.
Big R double, sorry?
Provided that r is not 0, right?
Yeah, because then if r is equals to 0, then you just have 0 as the answer.
Mm-hmm.
And that kind of, yeah. And then you have this. And then you can say that r prime is like you do a substitution essentially. You say this is a new variable, let's say u, and then this becomes like a first order dE.
Oh, okay.
Now you get
This,
r
what,
u prime.
E to the something, right?
Yeah, so then this would be u prime over u is equals to negative r.
Mm-hmm.
And then this is gonna be, it's like du over u is equals to minus r, I guess dt or something like that.
I think this is switched. This is switched, right? This is u over u prime.
Oh yeah, sorry. This is or I guess I'll do it the other way. Minus 1 over r.
Yeah, minus 1 over r. Yeah, good.
Yeah, and then so you get ln u is equals to ln r.
Mm-hmm.
Or sorry, this is not a dt.
No,
dr.
Dr. Yes.
Yeah, this is dr. So you get negative ln or negative ln r, which you can then turn this into
U is equal to r?
Ln u is equals to ln of 1 over r.
Ah, okay, that's it. Yeah.
Yeah, and then there's like a plus c or something in here that you can do. And then, but yeah, like you can take care of these essentially at the end. And then, yeah, as you said, u is 1 over r. And then u was r prime. So then you get r prime is equals to 1 over r.
Oh, so there's another ln in there.
R is ln r. And then there's like, because there's a plus c in here, this becomes the coefficient in front. And then that's where the coefficient comes from.
Cool.
Yeah.
Make more sense, noise?
Let's see
if you respond.
Yeah, this was a cool question because, like, I feel like this is something. I don't know. Did you see this a lot in physics?
No. I mean, this is what is this? Is the Laplace operator in spherical coordinates? Is that what all this is?
Yeah. So I wanted to actually like the first part of this, which was the long part. I was like, oh, let's actually get the Laplace equation.
Yeah.
From the normal definition of it that is
of a del operator. Yeah.
Yeah, onto the spherical coordinate.
Yeah.
And then this is a good practice because, first of all, you change your basis.
Yeah.
And 2, you're essentially working with a bunch of
spherical coordinates, sines and cosines.
Spherical coordinates in like chain rule.
Yeah.
So.
Yeah, no, this is I probably did like a derivation of the Laplace operator at some point.
Yeah.
But yeah, I was saying a lot of this actually I think I went through in vector calculus. I think a lot of this was vector calculus also.
Yeah, I went through this actually in complex analysis, which was
Yeah, maybe it was complex as well. Yeah, it could have been complex.
something that I was like, oh, this seems like either we should have gone through it in like calculus or physics,
Yes.
because this is essentially just how the gauges work in physics,
Oh
where
my
you
god,
have the
gauges. I need an education on
potential.
gauges sometime. I still don't know what a gauge is.
Yeah, but, yeah, like I was a lot of it honestly was also me going back and relearning everything, because
That's cool. Yeah, no, that's the great thing is you learn something the best when you teach it to somebody else, right?
yeah.
So there's kind of a dual benefit to that. Like, all right, nice, cool. Noise Story says yes, he got it. Awesome. Okay, Habib, let me do your question because you've been waiting for a while. Let me do Habib's real quick, and then I will get through everyone's questions today. Don't worry, we're gonna do it. All right, Habib, what's up? You're in the chat. Yeah. I think I saw him somewhere. Which chat would this be in? Okay, here we go. Okay, point A, B, and C are on the circle. It says, which of the coordinates is equal to the sine of 4 pi over 5? Ooh. Okay. Ew. 4 pi over 5 is not a nice number. It's not one of the nice, like, square root of 3, square root of 6. Or, sorry, pi over 3, pi over 6, pi over 4. Okay. Okay. Sine of 4 pi over 4. So let's figure out like what this angle is. So 4 pi over 5 is like just less than 5 pi over 5, which is the same thing as basically 180 degrees. Okay. So it's got to be something like right here. Okay. So this is what we would say the sine is equal to. Oh, I see what they're going to do. Man, I wish they actually like labeled like a little bit more. They should have labeled some things here. They didn't. It's okay. Which of the coordinates is equal to the sine of 4 pi over 5? 4 pi over 5 is a little bit less, so that's going to be like right. Let's just say it's this one. I don't agree that it is, but let's just say it is. Okay. Sine of an angle, let's remember, is the opposite over the hypotenuse, okay? Hypotenuse is always 1, all right? So I need something where the opposite here is going to be positive. Okay. So opposite, right, if I make this triangle, okay, opposite is going to be this part. This is the opposite. Whereas this right here is the adjacent. Okay. 4 pi over 5 is a little bit less than 180 degrees. I'm going to assume that point A here is like a little bit less than 180 degrees. They should have marked like what the angle here is. So Habib, if I'm looking here, right, at this triangle that I've made, let's say this is 4 pi over 5. All right. What is the opposite going to be in terms of these points? So remember the opposite is this. What is that in terms of this point A? $90? Not quite. So let's remember this point, right? This point A here has an X and a Y, okay? The X coordinate of this point, right, is going to be this. This is going to be the X coordinate. Whereas this right here, this is going to be the Y coordinate of the point. Remember when we plot points, right, in terms of X and Y, X is like how far I go this way, Y is like how far I go this way. So, yes, good. So this point A, right, has an X and a Y. And here, let me put this on another screen just so it looks nicer. If so remember, this is X, comma, Y. If we were to draw, right, a triangle like this, okay, where this is going to be my angle theta, then this portion right here, this is the Y coordinate, right, of the point. Whereas this right here is the X coordinate of the point. Where you could kind of draw it like this, right? See how that's the X. And then this is the Y coordinate of the point. Whereas this right here is the X coordinate of the point. Where you could kind of draw it like this, right? See how that's the X. okay? And for sine of an angle always looks at the opposite over the hypotenuse, okay? So if I draw my angle and then I create what's called like my reference triangle or reference angle, then looking at this triangle, the opposite is going to be this side right here, this side, okay? Which that's going to be the y coordinate of A. Does that make sense? Tips for pre-calc? Yeah, this is a good tip for pre-calc, honestly. Sure? He says sure. Okay.
That's dope.
I'm glad you say sure. Okay. I'm gonna ask you another one here. you're gonna get it. All right. What if I asked you? Okay. What if I asked you which of these coordinates was equal to, let's say, the cosine of negative pi over, which one do I want this to be? Let's say this is pi over 6. Yeah. Okay. The whole unit circle is very confusing to me. Okay, that's all right, dude. Here, this actually works because there's another guy in the TikTok that's asking about this. Let me just go with the unit circle real quick. Okay. Unit circle sucks. I know. No one likes it. Teachers really just send it to you and then they're just like, "Oh, figure it out, man." Okay, cool. All right. This is all the unit circle is. Man, if I can draw a line today. Okay. All right, and then let's do this. Okay. Habib, do you know what unit means? You ever seen the word unit? What does unit mean? I know unit means like feet and like meters and like seconds and whatnot. It means unit. Yes, unit does mean unit. Okay, all right. But unit also means one, is what we say. When we say something is like unitary, it means there's just one of them. Okay? That's what unit means. Okay. The reason why it's called the unit circle is because it's a circle where the radius of this circle is always equal to 1, okay? So, if let's say this is my radius, right? It says that the radius of this thing is always equal to 1, okay? Always equal to 1. This thing, all right? Okay. Now, gotcha, good, okay. So, I can take an angle here. Do you see how like I can move this at different points and like this will make different angles? Say for instance this makes an angle here, but then like I can move it over here and then it would make a different angle here. And then I could move it over here. Whatever. It makes like another angle, right? Yes? Good. Okay, cool. All right. It turns out that there are certain there's really 2 triangles you need to know. I'll explain them real quick. 2 triangles. This is on this TikTok that I sent to Sonic, but there's the 30 60 90, and then there's this one, the 45 45 90. Oh, you do know this part. Okay, great. Okay, awesome. Then let me show you where it comes into play. Okay, and then just know that 30 is pi over 6, 60 is pi over 3. And then 45 is equal to pi over 4, okay? And it's just multiples of those, okay? And then, okay, this is maybe the part that's different from what you've learned, is that the hypotenuse of all of these triangles is 1. So in this case, this is square root of 2 over 2. This is square root of 2 over 2. I see sometimes teachers will say this is equal to square root of 2, and then they say this is equal to 1, this is equal to 1. Technically works as well, but I like this method better, okay? This is square root of 3 over 2. This is 1/2. Have you seen this part, Habib, before? Or did your teacher probably did it this way? Probably did 2 square root of 3, 1. Was this the way that they did it? Or did they show you any triangles, the 30, 60, 90? We did the 45, 45. Yeah, okay, yeah. Yeah, okay. Yeah, the 45, 45 is an isosceles, and that's where this is 1, 1, square root of 2. But I'll show you why. I always want the hypotenuse to be equal to 1. I always want the diagonal to be equal to 1. So I'm going to divide everything by square root of 2. And when you do that, you end up getting this. You get 1 square root of 2 over 2, square root of 2 over 2. Okay. Tau is greater than pi every day. What is that? What is that noise? Noise speaking some code here. Okay. All right. So, Habib, if I have, let's say, an angle here. Let's say this angle is going to be pi over 6, okay? Which is the same thing, right, as 30 degrees. This is something you're eventually you're gonna get in the habit of. You're gonna know that, oh, I see that angle in radians, I know what it is in degrees. What you always want to do once you get an angle is you want to draw this angle on a unit circle, okay, Habib? And then you want to create what I call as a reference triangle, okay? Reference triangle means I'm going to take, do you see how this, right, 30 degrees is right here, right? And it comes all the way out here to the end of the circle. I'm going to create a triangle. You always make the triangle connecting whatever this is, this point here. This is a point, right? This is a point with X and Y, right? You always connect it to this axis, okay? Now what you have is you have a 30, a 90 here, which means this must be 60. This is the 30, 60, 90 triangle, all right? Where this triangle always has, right, a radius of 1. The hypotenuse is 1, okay? So in order to figure out the other sides, I go back to this triangle that I know. So I know opposite the 30-degree side, there's a 1/2. See, opposite the 30, there's a 1/2. And then opposite of the 60, there's a square root of 3 over 2. Okay, Habib? Does that make sense so far? Yeah, okay. Now that I have my triangle, I can calculate any trig function that I need to know, okay? I can calculate sine, which is equal to the opposite over the hypotenuse, by looking at this triangle and seeing what is my opposite, what is my hypotenuse, okay? So looking at this triangle, what's the opposite of this triangle, of this angle? What's the opposite? This angle right here. We're always talking about this angle. We always talk about the angle that is made between the hypotenuse line and the x-axis. That's always what we say. 1/2. Yes, good. You see how this is opposite of this angle, right? This is 30 degrees, right? So this is 1/2. And the hypotenuse, what's the hypotenuse equal to? 1. Good. So do you see here how the sine of pi over 6, which is the same thing as the sine of 30 degrees, is equal to 1/2, right? Because 1/2 over 1 is just 1/2. Yeah? Cool. Awesome. You can do the same thing to find the cosine. Cosine is the adjacent over the hypotenuse. See how this is the adjacent? That would be this over 1. That's square root of 3 over 2. And then the tangent is the opposite over the adjacent. So that ends up being 1/2 divided by this. And then that ends up being square root of 3 over 3, I think is what it is. Yeah, okay. Quick little thing. I want to show one thing that there's a lot of parts to this, but this is a little introduction to it. Again, if you really want the explanation of all of it that I have for all the angles, please watch this YouTube. Here, I'm gonna copy this text. I'm gonna paste it in here. There you go. Please watch that. That I've made so many of these videos because I've explained this so many times, but it's okay. It's been a while since I've explained it, so I will explain it again this time. All right, let's switch things up, okay? And let's say that the angle is more than 90 degrees, okay? Such as it was in the case of your original question. Your original question said, which of the coordinates was equal to sine of 4 pi over 5, okay? So, first of all, 4 pi over 5 is not a nice angle that we're going to use, so I don't really care about it right now. But I'm going to use, let's say, the sine of, let's say 5 pi over 6. Actually, let's do the cosine. I want to do the cosine of 5 pi over 6, okay? I hate this unit. I know you hate it, but I know. It's the most important thing you learn in pre-calc, though, in trig. Just like knowing this will help you out so much more later in life. Just I wish I wasn't as scared. I wish it was taught to me this way when I was in high school, because even all through college, anytime I saw sine and cosine, I freaked out. I didn't know what to do. I was so mad because it's not that bad. It's just it has to be taught correctly. Okay. All right. 5 pi over 6. Let's figure out where that is here, Habib, right, on our unit circle. So if 5 pi over 6 doesn't look nice to you and you want to put it into degrees, you can put it into degrees. And the way to do that, right, is 5 pi over 6 times, 180 over pi, okay? So that's, 180 over 6, that becomes 30, pi over pi, whatever. So that's 150 degrees. Do you understand that much, Habib? You understand how I got 5 pi over 6 is 150 degrees? No. Okay. Well, that's all right. So here, because 5 pi over 6 kind of doesn't look like a nice thing, right? I can't really visualize 5 pi over 6. I mean, I can now, but at your age, I probably couldn't. So converting radians to degrees, okay? Whenever you have something in radians, so let's say this is, for instance, 5 pi over 6 radians, you just multiply that by 180 degrees is pi radians. This is what we call like a factor. It's a conversion factor is what it is, okay? Do you know this? Do you know that pi radians is 180 degrees? It's okay if you don't. You do now. Okay, I'm glad. First step, understand how to convert radians and degrees. Okay. Yeah. Also, so going around an entire way, 360 degrees, how many radians would that be? Close. All right, so 360 degrees. So let's remember, it's 180 degrees is equal to pi radians, okay? That's the distance to go one around. That's pi. If I want to go all the way around, right? How many radians did I go? 2 pi. Yes, good. This is 2 pi radians. Good to know. Okay. All right. So if I take whatever my number is in radians and I multiply it by 180 over pi, this will give me the angle in degrees. And so what I did here, this is an algebra trick, is instead of multiplying 5 by 180, because that would suck. I don't want to do that. That's a big number. I'm going to do the 180 divided by 6 first. Okay? So instead of doing 5 times pi times 180 all over 6 times pi, right? I'm going to rearrange this to do 180 over 6 times 5 times pi over pi. Okay? This is called, I think, the associative or commutative property of multiplication. All I'm doing is I'm just switching the orders of things I'm multiplying. And in doing so, right, I'm canceling this with this, or really this with this, so that I get 180 over 6 is something that should be a little bit easier to calculate in your head. This is just 30. Because remember that 18 over 6 is just equal to 3. So you put another 0 on it, it's another 0. Commutative, yes. Okay, thanks, Noise. Yeah, I always forget which one's which. I think associative is the one with like the parentheses and stuff. It's like A, B, C or something. Yeah. So many of them. Okay. This is 30. And then we're multiplying by 5 pi over pi. Pi over pi is just 1. So this is why 5 times 30 is the same thing as like 5 times 3, which is 115. Which is, sorry, which is 15. Put another 0 on it, 150. Okay. This is how I converted 5 pi over 6 to 150 degrees. Does that make sense, Abim? How we got that? These are other tricks. Yes. These are tricks that you should know just regardless of algebra or regardless of trig. Like, you should know these tricks. It'll help you out. That's associative. Okay, cool. Thanks. Okay. So, 150 degrees. Okay, I know this is the same thing as the cosine of 150 degrees. All right, awesome. Where is 150 degrees? What quadrant is 150 degrees in on this circle? The second one. Very good. Good. Yes. All right, so we're going to draw that. Okay. Because I know, right? I know that as I go this... Okay. This is like 90 degrees, like right here, right? And then this would be 180. So 150 should be somewhere in between here. So we're just going to put it here, right? And I'm going to say that this right here is 150 degrees, okay? The next thing to do is to draw what's called the reference triangle. The reference triangle, again, is connecting this endpoint here to the x-axis. Do not connect it to this axis. Don't do that. Like, don't draw your triangle like this. Don't do that. That's wrong. That's wrong. Don't do it. Don't do it. Okay. Always connect the triangle to this axis. So I'm gonna take my point here and I'm gonna slam it down here. Okay. This is my new triangle I have. Okay. Now, let's remember that the two triangles I need to know are these. Let's pull them in. We'll get to those later. Okay. So if I'm looking at this triangle here, right? What is this angle right here going to be? $30. Good, right? Because this whole thing is 180. This is 150, so this should be 30 degrees, okay? Now what I notice, right? Here's 30 degrees. That means this is 60 because this is 90, right? We have a 30, 60, 90, which is this triangle, okay? Yay. So I'm going to label my sides of this triangle according to this, okay? So knowing that, what is the length of this side going to be? How long is this side of the triangle? It's okay. Yeah, this side is 1. You're right. This side is 1. Yeah, this side is always 1. No, it's okay. It's okay. Yeah, the hypotenuse is always 1. Good. 1/2, right? Yeah, okay. Very good. 1/2, right? How long is this side? Square root of 3/2? Yes. Now, there's a tricky thing to this. One thing you got to remember here. This is now on what we say is like the negative side of the x-axis, okay? So instead of saying square root of 3/2, I'm going to say negative square root of 3/2, okay? Because it's over to the left on the x-axis, okay? Yeah. Similarly, right? Let's say our angle was like here or something. And let's say this was 30 degrees, okay? This would not be 1/2. This would be negative 1/2 because it's below. It's in the negative area of the y-axis, okay? So you got to be careful when labeling. And again, they sometimes call this the y, and they call this the x. You can also call this the opposite, and you can call this the adjacent, okay? Makes sense? Yeah, good. Because this is negative x, and this is positive y. Okay, good. All right. So if I ask you now, what is the cosine of 5 pi over 6, which is the same as the cosine of 150 degrees, which we know is the adjacent over the hypotenuse, what would you say the answer is? One second. All right, drum roll. I need to get like a drum roll thing. That'd be kind of fun. Yeah, take your time. Take your time. I want you to get this right. Negative square root of 3/2 divided by 1. Yes. Very good. Right? The adjacent was negative square root of 3/2. The hypotenuse, right, was 1. Dividing anything by 1 is just negative square root of 3/2. Yes, good. There you go. Nice. GG. Yeah, does that make more sense? Does that make more sense, the unit circle? Unit circle fucking sucks, dude. Yes? Okay, good. Yes. Please, I know we just went over that just right now, and you might forget it. It's okay. But that's why I have all these TikTok videos on this one. You still hate it. I know. It's okay. You'll get the hang of it. It's just a lot of practice. And again, there's only 2 triangles you need to know. And then those are the tricks. There's some other things for when you hit like the 90, the 180, and the 270 that I can go over at a different point. But for now, that should help you out. Yeah. All right. Nice. Okay. Noise, you still here? Coolsies.
Is my question up next?
Yours is last because you posted last.
Yeah, but I thought when you were finished with his question, it would be mine.
Well, yeah, well, why do you think that? Because Noise's questions was before Habib's, but Habib's been waiting a while, and I want to make sure Habib got that. Average unit circle enjoyer. Yes. Okay, here we go. Which one should I do, Noise? 8 or 9? Pick one of them. Weirdo. 8 is fun. Okay. Did you know about this one, Ramton? You know about this Vietta's theorem, dude? Vietta's formula?
I haven't heard of it before, but
I just
yeah,
remember this is the basic way to do quadratics, but apparently it can be expanded out to like any power.
yeah. So like essentially, I always find this by reverse engineering.
Uh-huh.
Like this is the reason I kind of am used to doing something like this is because in perturbation theory you're always like grouping like terms.
Oh, by
so you
the
just
order
write
of the
out like that.
powers. Like the power of the terms, basically, right?
Yeah, exactly. And then you just group all of the things with the same power together. And so like you can reverse engineer. You can assume the solution and then expand it.
Mm-hmm.
And then you put together all of the terms with the same like powers.
Like what should be what? Yeah. Okay. Let me see. Is
Yeah.
this 8i is fun? He says find the equations. So this is I remember seeing this one. So from what I saw, it was if we add the roots together of all these things, these should equal. Wait, what was it? What was it? I had it earlier. What was it? No. It was on. One second. On this page. And then let's see how the reverse engineering method works. I'm curious. Okay. There we go. This was the rule that I remember seeing. Okay. Root 1 plus root 2 plus root 3 must equal negative b over a. So it must be this one over this one. Okay. So 2 alpha plus 2 beta plus 2 gamma must equal negative b. So that's negative 2 over a. It must equal 2. Okay. Okay, well that just tells me that a plus beta plus gamma must equal to 1. I like that. And then also that if I multiply them together, I have to get d over a. So if I multiply all these together, I have to get, negative d over a. I have to get negative 2. So alpha, sorry. 2 alpha, 2 beta, 2 gamma, all multiplied together must be equal to negative 2. Ooh. Oh, this is interesting. Okay. And then what is this? Is this like the round robin of all of them? R1, R2, R1, R3, R2, O3 must be C over A. So that's negative 1. Okay, so 2 alpha, 2 beta, plus 2 alpha, 2 gamma, plus 2 alpha, no, plus 2 beta, 2 gamma. That must be equal to C over A, ABC, so negative 1. I think I misread the question. Oh, did I? Oh. Well, how did I misread the question? Show me, Noise. What did I misread? Oh, find equations. Oh. Okay. I thought we were solving for what the roots are. I got you. You're so right. Okay, fine. You're right, Noise. Thank you. This is what happens after an hour and 26 minutes of streaming. I don't read questions anymore. Okay. AB gamma. Okay. Find the equations which have roots 2AB, 2A, 2 beta, 2 gamma. Okay. A plus B plus gamma has to equal to negative b, so that's equal to 2. So if the roots are now double that, that's multiplying these both by 2, okay? So that means that 4 is equal to negative b over a. Cool. I like that. Okay. A, B, I'm just gonna call it ABC because I hate writing the Greek letters. ABC was equal to -2. So if I double all the roots, okay, that's multiplying it by a factor of 8 because that's 2A, 2B, 2C, okay? So, ooh, yeah, okay. So 8ABC would be equal to -16. So, yeah, okay. -16 is equal to D over A. And then the round robin of them all. Okay. So that's going to be a factor of 2 on each. That's a factor of 4. Okay. So, and then C over A was -1. So -4 is equal to C over A. Am I doing these right? I think I'm doing these right? Oh, -D over A. Yeah. Thank you. Uh-huh. Very cool. Okay. All right. These all have A in it. So 4A is equal to -B. -16A is equal to -D. And -4A is equal to C. Okay, that tells me... What does that tell me? C and B are the same then? Is that right? Does C equal B? I think C equals B at this point, right? Oh, and this is gonna be one of these basis things, right? Where I just need the lowest one that works. Yeah, okay. Okay, C equals B, and then D is equal to -4 times B, I believe. Yes, yeah, we can just cheat and assume that A is equal to 1, right? Yeah, that's what I was gonna say. Yeah, right. Okay, that's cool. Okay, so it must be x cubed plus x squared plus x minus 4. Is that right? Did I get that right, Noise? Let me see. You did give me you gave me a cheat sheet somewhere. No, this is not right. Oh no. What did I do wrong? Oh, I'm dumb. I'm so dumb. Sorry, my bad. No. These are all multiple. Yeah, no. I screwed this up. Yeah, no. A equals 1. Okay, good. All right. So, it's x cubed minus 4x squared, right? Minus 4x plus 16. Yeah. Yes, that one's right. I know that one's right. Yeah, cool. I learned something today. I love it when I learn something. Noise, that's so cool, dude. I like that, dude. That was a cool one. I was gonna see how I could like reverse engineer like what they are, but oh wow, that's a very cool one. Did you get that, Ramton? I thought it was pretty cool.
Yeah. No, this is cool.
It's like a puzzle.
I like it.
Yeah, this is where like math gets fun. 'Cause it's like puzzle math.
Did you want me to like say what I mean by
Yeah.
reverse
Show me. Yeah,
engineering?
show me what you mean by reverse engineering. Can you do this one with
Yeah.
reverse engineering? I'm just curious.
Yeah, I mean, it's essentially just the backwards way of, or not backwards, but it's kind of like similar way of doing it. Like semi-backwards, I guess.
Yeah, let me put this on a new page for you, so you can just write it.
So you have.
There you go. New page.
Yeah. So you have if you have something like this, let's say I want to find like alpha, beta, and gamma, like if I wanted to find that, then what I'll do is I assume that, so these are the roots, right? You can always say, like, let's say we have 3 roots, and you say x minus alpha, because by definition these are the roots, then the equation can be written this way. And so we can see that if x is equals to alpha, x is equals to beta, or x equals to gamma, we get 0. Right? So then to find the to find all of the different terms, all we have to do is just expand this. Does that make sense? Wait, I don't hear you, by the way.
You don't hear
I
me?
don't know.
What?
Oh, there we go.
Yeah.
Now it works.
Okay. Yeah, no, this makes sense so far. I get it.
Yeah. And then so if I wanted to just find all of the terms, so like this term has no x's, so it should just be the multiplication of all 3 of these. So then it would be minus alpha times minus beta times minus gamma is equals to 2. So it's minus alpha beta gamma is equals to 2, which I think is exactly the same other formula as the one noise posted. Yeah, because that one's minus d over a. Like for this one, you can always assume you've divided by the coefficient of the biggest thing, just so that
so it's 1.
Yeah, just so you
Yeah.
can have all the coefficients of the x to be 1.
Uh-huh.
Because since it equals to 0, it doesn't really make a difference anyways. And then and the roots are still going to be the same thing, so it's just easier way of dealing with it. And then if you want the x term, then you're going to have to figure out the different ways of getting x. So you can get, let me erase these arrows. Oops. Where did it go? There we go. Yeah, so if I want an x, then it has to be like this times this, and then this times this, let's say. So it's going to be beta, gamma. That's one way of getting x. Another way is like this times this, times this times this. So you get plus alpha gamma. And then you'll have this times this, and this times this.
I see all the cross terms.
Yeah, exactly.
Ah.
Is equals to 0. So then, I think that's the other. Yeah, so that's going to give you this one.
Right.
From the previous thing. And then, yeah, once you. And then if you want the biggest term. So
and it's not equal to 0, though. It's equal to c, though, right?
Sorry?
Is it? Oh, no, it is still equal to 0, though. I get it. Okay. Wait.
Oh, no. You're right. No. I don't know why I wrote 0. You're absolutely correct. Yeah, so this would be the coefficient of the terms with x in there.
Right, which is c.
So,
Yeah.
So this is minus 1.
Mm-hmm.
Yeah, you're right. And then for the x squared, it would be 2 x's and 1 not x in there. Mm-hmm. So it would be minus alpha, minus beta, minus gamma equals to minus 2. And then, obviously, if you have divided, then the last one, by default, should just be 1 equals to 1.
Uh-huh. So, it says you can also say x equals 2 alpha, alpha equals x over 2. Oh, substitute and expand. Yeah, you could do that too, I guess.
Yeah. So I think with the other formula, you just have, alpha plus beta plus gamma equals to minus 2. So, that's why they have the minuses on the other side, I guess.
Yeah.
But the way you write it in terms of the roots, it works like this. I mean, the reason I know this is because of the perturbation theory.
Yeah. When you're trying to group by orders, you're like, okay, what are my coefficients? This also works with like partial fractions, right? Partial fractions uses this a lot.
Yeah.
Yeah,
exactly.
That's cool. I always find it cool how these skills they overlap, right? They go into all these different fields. It's the same thing. It's the same algebra skills you need to know.
exactly. It's just like tricks. Like I guess someone always like goes and proves that this works
Yeah.
as well. Like sometimes uh, so I guess one rule uh of math, I think this is kind of a cool thing because once you notice, there are times that you can know when you can completely guess and when you can't guess.
Uh-huh.
If you ever have infinity, don't guess.
Don't guess. Just don't do it.
Don't guess. If you don't have infinity, if you don't have infinity, you don't, or I guess the better way of saying it is that this needs proof.
Uh-huh.
This one doesn't. Because
Because you can do inductive reasoning or something. You say like, oh, if it works for n, it works for n plus 1.
Yeah, because you have a finite amount of things, so you just have to like calculate and then show it works.
Right.
And then nothing ever funky happens because there's nothing like shady going on because there's no like.
There's no
these
infinity
things...
over infinity. This is like yeah. Oops. No, we don't know what that is. You know, this is usually 1, but nope, it's not.
Yeah, because the infinities could have bigger, like it could have different sizes. That's what.
Yeah, I was, yeah. Like infinity is a concept. It's how big is your infinity?
Yeah, exactly. I mean, the easiest way I always tell people is like if you have x over e to the x, and take the limit as x goes to infinity of this, right? One looks like this, and the other one looks like this.
Oh.
So although they both go to infinity, one of them goes there much faster.
Right.
So since the exponential goes a lot faster, then you're like, this is technically gonna go to 0 because this one is gonna be much bigger than this one.
There's the whole ordering, right? There's the, you know, x is smaller than ax, which is smaller than what is it? X to the a, which is smaller than a to the x, which is. I'm trying to think what the other ones are.
Okay.
You ever seen this? The orderings of as which one is the bigger infinity?
Yeah, I mean you can always what's it called?
My infinity is bigger than yours. Yeah, noise. Are we gonna have an infinity size war?
Yeah, yeah, I think I've seen something similar to this. And then factorial is gonna be bigger than that.
Factorial is bigger than it? Yes, you're right. Is factorial the biggest daddy? Is this the biggest daddy? X factorial? Nothing's bigger than X factorial. Besides like X, what about X to the X though? Ooh. I think X to the X wins. Yeah, X to the X wins.
Yeah.
This is fun. You just like nerd out over like who has the bigger infinity. Yeah, I think X to the X is the biggest. Besides like X to the X to the X, you know, and then we're just getting silly. I'm sure there's some weird like Wagner function or something that describes this. I don't know. It's always something. Yeah, that's cool. All right, let's see. I think I got one more question. Let's roll through it. Ethan, what's up? Come up stage. I love my power towers.
Yeah.
Power towers noise. Yes, dude. Ow. Okay.
I'm here.
All right, cool, Ethan. All right. How'd your test on the Pythagorean theorem go, dude?
Yeah, I got an 85 because...
85? No! Why didn't you get 100?
Because I completely forgot. Did you ever hear of Pythagorean triplets?
Yeah, Pythagorean triples, dude. We've talked about them a lot, dude. Yeah.
I forgot. And he even said we could use a textbook, and I'm saying no.
These are the Pythagorean triples, Ethan. 3, 4, 5, 5, 12, 13. I forget what the other ones are. But these are the only ones you really have to know. And then the multiples of these also count. I've talked about these quite a lot. It's okay if you don't remember them, but like I know I've discussed these. But also like for instance like 6, 8, 10 works or 9, 12, 15. It's like
see
15.
that's the one. That's the one.
Was this one?
That is the one. Yes, that 9, 12, 15. I thought it was 11.
Yeah, no. Do you see how this is like times 2 and then this is like times 3? Yeah, it's just multiples of everything is all it is. Oh, sorry, I did this wrong. What am I doing? Right. Jesus, what am I doing? This is 10, and then this is 15.
So this one. 36. So the question I'm asking here is about trigonometry.
Yeah, it's okay. This is trig. Yeah. Yeah, look at Noise.
And you
Noise says, I see these every stream. Yeah, because I know Noise doesn't forget. Noise, can you imagine what I feel like, dude, when I teach the same topic every single stream? Literally every single. It's okay.
Yeah.
It's totally okay, because there's always new people watching the stream, and I'm fine. But doing it again so that another new person can see it.
Mhm.
But yeah, if you're someone like Noise, or if you're definitely someone like me who sees everything I do every single day, yeah, you would start to blow your brains out from being like, wow, how many times have I said Sokotoa? It's okay.
Oh, honestly, Dr. Go, we've done something similar to this.
It's okay.
I think I can do it in the beginning.
All right, show me the beginning. Show me where you need help. That's the perfect. Yeah, you show me what you need help with.
So, the first thing that the teacher does is labels everything. He
Good.
labels like the hypotenuse, the opposite, and the adjacent.
That's very good. Okay, cool. So on this triangle that you've drawn here, right? Which one's the hypotenuse?
The LM.
Good. Yeah, this is the hypotenuse.
And he said that the opposite is like to the other side of the angle that you're given.
Yeah,
So in
opposite is
this
always
case, it's
opposite the
KL.
angle. Yeah, good.
It's KL.
Mm-hmm.
And then for this adjacent, we just assume that it's KM.
Yeah, KM is always the other one. If it's not the opposite and it's not the hypotenuse, then it's got to be the adjacent. All right, yeah, so this is the adjacent. It's equal to KM.
Mhm.
Okay. All right, cool. Are you allowed to use a calculator
And
for this
then-
one? You don't need a calculator for this
Oh
one.
yes.
You are?
Well, honestly, he said that we can use a calculator.
Okay. You don't need to, but yeah, you can.
So then we got the Sokotowo method, which I obviously know it by now.
Good. Okay. Glad you know it. All right, what is it?
And see that, well, it's Sokotowo, so it's like the sine of an angle
Good.
Same
angle.
is equal to the opposite of the over the hypotenuse.
Very good.
And then the ka, which means cosine of an angle,
Mm-hmm.
is equal to the adjacent over the hypotenuse.
Yes.
And then you got toa, which is the tangent of an angle, which is equal to the opposite over the adjacent.
Good. Very good. Yeah.
You see, I've done that before.
Okay, good.
And then the problem here is just figuring out which one it is.
Yeah, good. Okay. Yeah, well, let's do it piece by piece. We're looking for KM. Which side is KM?
KM is to where the where you can find the angle at the 60 degrees.
Okay, good.
But I feel like I know how to do this. I think.
All right,
I
then
think
try it.
it's
Try
gonna
it.
be I think it's cosine. I think you gotta use cosine.
Good. Yes, because the adjacent, right? That's what KM is. So we want to use the one that has the adjacent in it. But do you see how I also need the hypotenuse? I don't have the hypotenuse yet.
Yeah.
What side do I have?
You have the adjacent side.
No, I'm looking for the adjacent side. What side is
well,
this?
you have the opposite.
Good.
You
You
have
have
the opposite side.
So I need something that has the opposite and the adjacent in it.
So that's tangent.
Good. Yeah, see? Noise says, woo, tangent. Big tangent enjoyer here, dude. Yeah, good. Okay. Yes. So we're going to use this one. Okay, how are we going to use that one to figure it out?
So we basically just use tangent and we use the angle that they give us, right?
Uh-huh. So what's that going to be?
So it's gonna be like tangent 60 degrees
Good.
is equal to 10 centimeters over.
I think this is 12.
Adjacent.
I think this is 12.
Wait, hold on. I need to check that.
Or maybe it's 10. I don't know. Can't tell you. Twos or zeros. Zoom, enhance. Zoom, enhance.
Oh yeah, it is 12. It is 12.
It's
It is 12.
Okay, cool. Okay.
Well,
so
it's
good.
12 over the
Over the
adjacent.
adjacent.
It's 12
Okay.
centimeters over the.
Okay, this is a good algebra question. How do I solve for the adjacent, even though it's on the bottom?
Hold on. He said that we have to calculate the tangent or the thing for the angle.
Yeah, we can.
So you just want to do it? You just want to do the thing?
Yeah, so I could calculate the tangent of 60 degrees using a calculator if I wanted to. And here, I'll just show you how to do that on a calculator. It's okay. Or I can use the unit circle, because 60 degrees is a nice angle. Okay, so tangent is 60. That's going to be, well, that's ugly. All right, so whatever. I'm just going to, I'm gonna leave that how it is. Wait, is this in degree mode? Yeah, this is in degree mode. Okay. The real way to do this is if I have from, okay, this is where things go way back. Do you remember this triangle, Ethan, when I was teaching you this? Or I was teaching Habib this.
Habib, yeah. Habib was the one who was
Do you see how
taught by this.
this was the 60-degree angle in the triangle?
Yeah.
Do you see how this is the opposite, and then the adjacent is 1/2?
I see that.
So if I do the opposite over the adjacent, that's square root of 3/2 divided by 1/2. In this case, the 2's cancel, and we just get just square root of 3. Okay, so that's what the tangent of 60 degrees is. Bringing it all back. Yes.
So you gotta do like 3.
Square root of 3. Square root of 3. So that's what this is. Okay, and you can see it on the calculator as well. See what I did? I manually did tangent of 60 degrees. I got that.
Do
you see how square root of 3 is the same number?
Okay.
Yeah. That's
And
the
so
proper way
and
to do it.
so I think you gotta do something else with this.
What do we gotta do?
The teacher said that you will have to cancel the 12 out, I think.
So, do you see how the variable I'm solving for is on the bottom of a fraction?
It has to be on the top.
Has to be on the top. How do we put it on the top?
Well, we switch it around.
Yeah.
And you go and then you do the same thing for the square root of 3. So
Yeah,
you
good.
do 1/, square root of 3.
Good, very good. Is equal to the adjacent over 12. Yeah. So all I did is I did like flipsy. Flipsy. Yeah.
And then what you gotta do after that is like multiply by 12 for both sides.
Yeah, it's good. So 12 over the square root of 3 is equal to the adjacent. Very good. Technically, this is the correct answer. It's not the nicest form. Do you know why this is not the nicest form, Ethan?
Because you still got you got to divide like 2 things or something.
Well, so I still
You
have
gotta figure out
a
two
square root of
things.
3 on the bottom. I have a square root of 3 on the bottom, right?
Yeah. But could
Okay.
you try to solve that?
Yeah, so here's what you can do. If you ever want to get rid of the square root of 3 on the bottom, multiply both the bottom and the top by square root of 3. Okay.
Okay.
You see how this is 12 square root of 3 over the square root of 3 times the square root of 3? Do you know what the square root of 3 times the square root of 3 is?
Isn't that supposed to just cancel out?
Yeah, it does. But what does it cancel out to be? What does square root of 3 times square root of 3 become?
Square root of 1?
Not quite.
Or is it just 1?
No, not that. It's square root of 3 squared. What happens when I have square root of 3 squared?
Wait, if you're saying you're square rooting these, then do you square them?
So this is good. 12 square root of 3 over, and this is something times something is the same thing as that thing squared. Right? Do you remember this, Ethan? A times A is equal to A squared.
Mm-hmm.
What happens when I have a square root times something? What happens when I have a square root squared?
Well, I think you gotta use a square root to you gotta divide the square root by itself.
No.
Not divide, multiply.
Yes, that's what's happening here. But anytime you have a square root squared, these go away. These cancel, okay? So you're left with 12 square root of 3 over 3.
All right.
Cool.
And then you can cancel out the 12 on the tree
Yeah, how can I do that?
by reducing the 12 and the tree by like
By what?
3
By 3, good. So what does the 12 reduce to?
4 square root of 3.
Nice. Nice, Ethan. Find the angle L. Let me do this just real quick for you. This is 4 square root of 3, right? You can do the same thing in order to figure out this side. You would just use a different function, right? A different trig
Hey,
function.
hold on. Hold on. They said that we can use like the Pythagorean
You
theorem for
can. You
this.
can also use the Pythagorean theorem, right? So you know that this side squared plus this side squared has to equal the hypotenuse squared.
Yeah.
That's another way you can do it. This
Or
ends
you
up,
could just use the same trigonometry.
you could use trigonometry again. This is 16 times 9 plus 144. I don't know. It's some big number, and you can solve for it. That's fine. The angle L, do you know how to figure out what this angle is?
I mean, that's like maybe the easiest step.
Yeah, what is
What
it?
I do is like use 180 degrees since that's the full degree of a triangle,
Good.
and then you do like minus open bracket 90 plus 60.
Good. Yeah, whole thing has to be 180. I already have a 60. I already have a 90 because this is a right angle. So plus what is equal to 180, right? So 180 minus, this is 150. What's that angle going to be?
Wait, hold on. Reverse back. Hold on.
Noise said I was going to use tangent again. Noise loves his tangents, dude.
Hold on. I'm trying to figure this out. Like,
Got it?
see, I'm not. Did you reverse back?
Yeah. Here, let me.
Because you added the 60 and the 90 already.
So
Oh,
this
okay,
angle
so
and this angle
So in this.
plus whatever this is have to be equal to 180.
Okay, well, what I can assume is that 180 minus 150 is 30 degrees.
Good. So that's angle
And
L.
so that means. And then that will mean the angle K must be 90, right?
Yes. Well, we said it was 90 because
Alright.
it has this. This thing always means 90 degrees.
That's what. Oh, all right.
And you need to have a 90-degree angle in your triangle in order for it to be able to do any sine cosine stuff.
All right.
Cool? Nice.
Yeah,
Good job,
cool.
dude. All right. Nice. Okay, sweet.
You see how many points I have? You see how many points I have there?
You do. You got a lot. 87, dude. You're almost up to another 100. I had someone in the TikTok ask about Lewis structures, but I told them, just give me an example. I'll do it. But I don't know. I got to work on engaging my TikTok crowd somehow. They come in and they watch, but they don't stick around for their questions. Is there going to be a game today? Yes. I'll play Fortnite with you guys. That's okay. I'll play Fortnite. I wanted to go to the gym, but I'll play Fortnite with you.
It won't be an hour though, right? Since you gotta teach someone.
I do have to teach, so maybe like 30 minutes. Tay. Well, let's get Tay up here. What's up, Tay? Wait, Tay, did you come from TikTok? Wait, one sec. Maybe Tay came from TikTok. What's up, Tay? Did Tay just join our server?
Also,
Where's Tay?
Also, I just spoke.
Oh, Tay
You have to
came from
go?
TikTok. Wait, one sec. Yeah, what's up, Ethan?
I hope the games go well today for Fortnite.
Yeah, I hope so too. Tay, come up. Come up, Tay. Where's Tay? I will do this because I very rarely have someone make it from TikTok to Discord to here. Tay, what up? When did he ask to come up? All right, let's see. I'll give him a minute or two. 5, 10, 20 hours? I can't do that long. Okay. You guys are crazy. Oh, there he is. He says, "Yo, what's up, Tay?" Also, Ramton, you don't have to stay for all 2 hours, please. Like, if you have to go do something, please, you do it.
All right, no, that's okay.
Right.
Yeah,
I know because this gets excessively
we'll
long
have
sometimes.
like 5 minutes or
Okay.
something ish.
Cool.
But today is Victoria Day, so
Oh, that's sweet. What's Victoria Day?
it's a national holiday, but I think it's about Queen Victoria. Not quite sure.
Was she the queen that resided when like Canada was discovered or something?
Maybe I don't know. I'm Canadian,
He's
so
like, I'm Canadian, but I don't know what our holidays are. It's okay. You know,
no, I'm not even
oh,
Canadian.
he's not even Canadian. Wait, but you live in Canada, right?
Yeah. I live
Oh,
in Canada, but like,
are you, oh, that's a good question. Are you
uh,
Canadian citizen?
no,
Oh.
not yet.
Oh, I got to change the Nightbot then because the Nightbot says you're Canadian.
That's okay.
That's okay. Where are you originally from,
That's
actually?
fine.
By the way.
None of my friends think of me as non-Canadian
Yeah.
because I've been here for like so long.
Yeah.
So like whenever I'm like, oh, like I'm doing my, visa stuff, and they're like, oh wait, yeah, I forgot you're not Canadian.
Yeah, you're not actually Canadian.
But yeah, hopefully at a very near future,
Is it as
it will
hard as
be.
it in the U.S.? It's a fucking nightmare to get citizenship, dude.
I think US is definitely
Yeah,
harder.
yeah.
I think I know US is hard regardless, but Canada it has been taking a lot of immigrants lately. Um, but and like because I'm a student and everything,
Uh-huh.
like
Oh, you're on like a student
technically,
visa.
yeah, like technically it should have been easier, but like none of the time, money, or anything that you do as a student counts. So it's kind of, you know,
That's
it's kind
you
of
would think they
like,
would you would think they'd want to reward like kids who learn in Canada, get educated by the Canadian education system. They want them to stay, right? To
yeah,
help the Canadian science or industries or whatever, right?
yeah. Yeah, you do get an edge in terms of like there's like a point system or whatever. Um, so you do get some points for getting in Canada, but like
Points are
in
nice.
terms of the fact that the time that you've spent in here, it's not relative. Because like if you like study in Canada, then you have to work, then you have to apply for stuff. It's gonna
Yeah.
take like 8, 10 years. But then if you come here on like work visa and you have lots of money,
Mm-hmm.
then it's gonna take you like 2, 3 years,
Yeah, you can just buy your citizenship basically.
pretty much.
Damn. Oh man, the plights of immigration. How do we solve it, dude? It's a problem. Let's see. All right, Tay's asking about Lewis structures. Are we gonna go for the world record longest office hour stream ever? I think we will, because I'm about to hit 2 hours. All right, but I will do this, Tay, because I appreciate you asking the question on TikTok. All right, let's do it for CCL4, because he says, I have my exam tomorrow, and I have no clue how to solve Lewis structures. That's totally cool, man. All right. I have a TikTok video on this. It's probably actually how you found me. You probably found my TikTok video on Lewis structures. If you don't know what it is, I'm going to tag you in it real quick, just so you can watch it later. So I'll still explain it to you now, but let's, just so you can watch it later. Here we go. How to draw Lewis dot structures. I think, well, that was part 2. Where was the hold one? That's double bonds.
Yeah.
This is it. Okay, cool. Got it. There you go. That's what that video is. But here, let me actually do this one for you. Okay. Lewis structures. Anytime you have a Lewis structure, they're usually going to give you some element, and then they're going to give you a bunch of other elements that are being attached to it. This first element is usually your center or central atom, is what we say. So in this case, I'm going to call this my central atom, and I'm just going to draw a C right here in the center, okay? And then what I know is I have 4 chlorines that need to attach to it somehow, okay? So I'm going to put the chlorines around it, all right? And then we're going to see how well I can connect this, okay? What I like to use is what's called like the bars method. So what I'm going to do is I'm going to see how many valence electrons are on each thing. And the way to figure out how many valence electrons there are is to look at the periodic table, okay? So we're first going to look at my carbon here and see how many valence electrons. Okay, so this is like 1, 2. This is something 2 or 3. You know, it kind of depends. This is 3. This is 4. This is 5. This is 6. This is 7. And then this is 8. So carbon, which is right here, is going to have 4 valence electrons. Chlorine, which is right here, is going to have 7. Okay? But I have 4 of them. Okay? So I'm going to multiply that by 4. So that means I have 28 valence electrons from the chlorine, and I have 4 valence electrons from the carbon. So that's going to give me a total here. I miss chemistry. Chemistry is, yeah, I like chemistry too. Noise, right? Chemistry is actually probably my second favorite subject to teach. I got 32 electrons. And then what I like to do is I like to divide this number by 2 So that's going to equal what I call like 16 bars. So, what's up, Riplaw? Does this make sense so far, Tay? Yeah, always type. If something's confusing or doesn't make sense, like, please, like, be like, I don't get this shit. Like, let me help explain it to you if you don't get it. You weren't taught to divide. It's okay, because they probably taught you to use 32 dots, but, like, bro, like, drawing all these dots, like, drawing 32 of them, I don't want to do that shit. That shit sucks. I divide by 2. I'll show you why. Okay? Because 16 bars to me, like, makes more sense. Yeah, Nightbot says he doesn't know either. Yeah, okay. So the first thing I need to do, Tay, is I definitely need to connect these chlorines to these carbons, and I need to do that at least with 1 bar. So what I'm going to do is I'm going to try to use 1 bar to connect each chlorine to the carbon, okay? So I've used 4 so far, right? So I'm going to subtract by 4, so now I have 12 bars left, okay? All right.
How long is this stream?
It's pretty long. We're at 2 hours and 2 minutes. 2 hours and 2 minutes.
You're not going to do recess.
We will do recess. I will do it. Don't worry. I want to explain to Tay how Lewis structures. We had someone from TikTok find us, so I was like, oh, I have to explain this to him because I want to encourage that more. Yes. Okay. Tay, does this make sense so far? How you have 12 left? Because we used up 4. Okay. The next rule is that you usually want every atom to have 4 bars connected to it somehow, okay? So what I'm going to do is I'm going to use up the rest of my bars to try to make sure everything has 4 bars around it. Each chlorine already has 1, okay? So let me put another 3 on each one, okay? Let's do this. I'm going to do this, yeah. Okay? Do you see how I put 3 on here? I added 3 here, I added 3 here, I added 3 here, I added 3 here. So I added another 12, which means we subtract 12 from here, and now I have 0 left, okay? Exactly, yes. Each bar is like 2 dots, and that's what the last step is. So what I do now is I look at every atom and make sure it has 4. Chlorine has 4, carbon has 4, all the other chlorines have 4, so we're good. And then the last step, yes, the last step is any of these bars that aren't connecting an atom to another atom, now you replace these with 2 dots, okay? So now this is just 2 dots. That's what I do at the end. I'll show you why I do that. But, yeah, you get the gist here. If I really wanted to delete all these. This is the pain of chemistry sometimes, just drawing all these things. Right, dot 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 dot, and that one's done. Nice. Cool. All right, let's do one more that's a little bit harder, Tay, because I want to show you why it can get weird, and that's when we have like double bonds and triple bonds. Does this make sense so far? These are like the easy ones. Okay. All right, let's move this over. Okay. The double bonds I don't understand. That's totally cool. Let's say they want you to figure out N2H4. Okay? This one looks kind of weird, right? Again, there's the first atom is usually the central atom, okay? In this case, there are 2 nitrogens, so I'm going to draw the 2 nitrogens together, okay? And then H4 means I need 4 hydrogens around it. Usually, chemistry likes things to be symmetric. So I'm gonna put I'm gonna put like 2 hydrogens on this side. I'm gonna put 2 on this side. And again, the problem with chemistry, dude, is there are exceptions to everything. So this is in general, but sometimes things will screw up. But we'll get to it. Okay. So here's a good question, Tay. How many valence electrons does nitrogen have? Yeah, 1 sec. Check the periodic table. Yeah, good. 5. Good. Very good. Nitrogen has 5. And remember, we have 2 of them. Okay? So that's a total of 10. Now, for the hydrogens, right? Thank you, Obama, for the sub. Appreciate it, dude. 17 months. Wow. 17 months on a sub. That's dope. Okay. hydrogen has how many valence electrons? 1. Good. And we got 4 of them, right? So that's 4 electrons, right? So that's a total of 14 electrons. I'm going to divide by 2 again. 7 bars. Okay? Now, I'm going to place my bars in different places, okay? I know I need at least 1 bar to connect the nitrogen and the nitrogen, right? I'm going to need at least 1 to connect each hydrogen to the nitrogen, okay? So let's look at how many bars that we've used so far, right? I've used 1, 2, 3, 4, 5, right? Let me make sure that's right. N2H4. Cool. Oh, wow. 18 months. Thank you, dude. Thank you, Elwin, dude. Appreciate that. Okay, 7 months. Yeah, okay. All right, we've used 5 bars so far, right? So this is going to go away. Now we're left at 2. Let me see one sec. What did I do this one real quick?
Here's an easier way to draw Lewis dot structures.
What did I do in this one? I need to make sure I'm right. Where did I do the N2H4? Was this the one with the triple bonds I had? Oh, I know what's gonna happen here. Oh, this is a very tricky one. Yeah. Yeah, okay, good. Yeah, watch, Tay. This is where this gets tricky, okay? I got 2 bars left, okay? So, here's the thing. Hydrogen only needs 1 bar connected to it. Hydrogen is kind of like the exception. Someone got mad at me on TikTok being like, hydrogen's not an exception. Chill, bro. It's kind of an exception because everything usually wants 4, okay? So, the hydrogens so far, these ones are happy. I don't need to put any more bars on the hydrogens. Hydrogen only needs 1. That's the exception. Everything else usually needs 4. But hydrogen just needs 1. The nitrogens, however, need 4. Okay? See how each nitrogen here only has 3, Tay? So there's a couple options here, right? So one thing I could do is if I wanted nitrogen to have 4, is that I could put a double bond in between here, okay? Because do you see how now nitrogen would have 4, right? Because it has 1, 2, 3, 4. And then this nitrogen has 4. 1, 2, 3, 4, right? Yeah, I did get called. I got called out by my chemistry teacher, yeah. Yeah, so this would be nice. The only problem with this is now I'm only using 6 bars, right? But I need to use 7. So in this case, this is wrong. Because this only uses 6 bars. I need to use 7. So when that happens, when, for instance, I need to make sure each has 4. This is where we have to use like a lone pair is what we have to do. I'm going to put a bar here and a bar here. Now I have 1, 2, 3, 4, 5, 6, 7, right? And each nitrogen has 4 on it, right? 4 bars attached to it. So what you end up drawing is like, yeah. Tell me if this makes sense, Tay. Tell me if this makes sense. You think you get it? Yeah, okay. Here's the other way to think of it. Like, fuck the bars. Don't even worry about the bars right now. Let's just look at, like, what I would need in order for this to have 4, right? I could put a double bond and it could have 4. The other thing I could do, the simpler thing, is I could just put a lone pair bond on it like this, right? Okay. So that ends up looking something like this. This is, like, more the symmetry of it, right? Dot, 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 dot. Okay. And this is okay. Because I have 1, 2, 3, 4, 5, 6, 7 bars being used. So this is all right, okay?
That's dope.
Where's my check mark? There we go. Yeah. Yeah. The first thing you should try to do is you should just try to put a lone pair on whatever is missing the 4 bars to see if it works out. In this case, it does. If I put a lone pair here and a lone pair here, I'm using 7, so I'm okay. Okay? And then I want to see what my other example was that I used, the one that gets complicated. Oh, is it NO2 that I use? Yeah, NO2 minus. Yeah, okay. Can you give a question that I couldn't solve? Well, which one? What do you mean that you can't solve? You should be able to solve everything. Everything technically has one. You mean one that would be tricky? Okay, that's okay. Yeah, let's try this. Okay. Here's one that can be tricky, and then I'll end on this one. Let's say we had NO2 minus. Okay, Tay? This could be a tricky one, right? Oh, an example from you. Yeah. Give me an example. Yeah, give me it. Yeah, give me an example. I'll show you how to do it. Please do. What's up, Riplaw?
I was gonna say anything with like one of the nitrates or sulfates.
Yeah.
That would be nice as well, like H2SO4 or something like
Oh,
that.
yeah, something with the polyatomic ions and stuff.
Yeah.
Yeah. He said XeCl4. Okay, you know this is interesting? This is the expanded octet is what this is. This is where... Yeah, I got you, dude. XeCl4. Remember how I said chemistry has exceptions, dog? This is the problem.
X? What the hell is XE?
Oh, sorry. Xenon. Sorry.
Wait, X... Oh, XE is Z... Oh, okay.
Yeah, isn't it Xenon? Yeah,
What?
XE is Xenon. Yeah. Do you guys have a different periodic table in Canada?
No.
Okay, yeah. Yeah, Xe is Xenon.
No, but... Wait, xenon is not even reactive, though.
It's inert. You're correct. But it can definitely bond to things. It's called... Yeah, it's an expanded octet is what it's called. Noise
okay.
says, fuck ions, dude.
That's dope.
Oh, man, dude. Noise
Yeah,
is
I
picking
think
violence.
that's what...
This is something. I'm
was
pretty... Xenon chloride is definitely something. I'm pretty sure it is. Pretty sure it is. Yeah. Xenon tetrachloride. It's unstable. Okay, well, it's not stable. Okay. I don't know. I don't know why they use it. Why do we use xenon chloride? I guess it's something in terms of beta decay. That's cool. I don't know.
Yeah, I think it actually decays because it actually has 4 extra
Valence electrons,
That's
yeah.
cool. I've never seen this. I mean, I didn't take chemistry past first year, but this is kind of cool.
Yeah. So Tay, what he was saying here is, so xenon is part of what's called the noble gases, which means it usually does not bond with anything. It doesn't need to, because it usually has 8 valence electrons. However, this is the problem with chemistry. There are exceptions in that there are things that we call the expanded octets, where certain atoms can have more than 4 bars connecting to them. They can have like 8 or like 5, or these are called expand. Let me see. There's expanded octets. Yeah, PCl5 is another one. Yeah, these are the expanded octets. SF6, that's another big one. Yeah. You end up just kind of like recognizing these in chemistry. Again, I've been doing it for a decade, so that's why I know them. But yeah, if you're seeing this for the first time, it's kind of like, yeah, sucks. But okay, you can still do it in the same way. We can still do it in the same way. Xenon has 8 valence electrons, right? Chlorine has 7 times 4. That's going to equal a total of 28 valence electrons. Okay? So this gives me a total of 36. Or what we're going to say is, divide by 2, 18 bars. Okay? For real, who's actually bothered past sodium, dude? I don't know. Yeah. We should just live in the salt world. Okay. Again, looking at this, XeCl4. Xe is probably going to be in the center there, Tay. So I'm going to put Xe right here. And then I'm going to put 4 chlorines on the outsides of it. Okay? All right? So now let's start to connect some stuff, right? I know I need to definitely connect these at least, right? So that's going to be 4 we're already using. And then I want the chlorines to be happy, so I want them to all have 4 bars on them. So I'm going to put an additional 3 on each, okay? So that's another 12, okay? So, Tay, how many bars do I have left? If I've already used 4 and 12, how many do I got left, Tay? Hi, Vesper. It's kind of like Vesper. Does Vesper explain the expanded octets? Yeah, good.
Nice.
Yeah, you got 2 left. Good, because we've already used 16. All right, I got 2 bars left. All right, nice. I got 2 left. I got to put them somewhere. I don't want to put them on the chlorines, and you can kind of see this in chemistry. If there's like some ambiguity of like, if I wanted to put an additional 2 somewhere, but I had to pick where it was, unless it's something called resonance, this is usually like you don't want to do this. If there's ambiguity of like where I put things, usually not right, unless of course it's resonance. But that would require me going into what formal charges. But you know, so what you're actually going to do is you're going to put these additional 2 on the xenon. Okay, so that's going to give you the 0 left, and you'll be done. And then so this is what's called xenon has an expanded octet, which means it wants more than just 4 connections. It wants more than I think they call these electron groups. It wants more than 4. And you know that's what they end up showing here. This is ZeF4. It's the same thing with Cl. So it has an additional 2 valence electrons. It has an additional 2 unpaired electrons on the outside. So we end up drawing is like a dot here, pair of dots there, sorry, and then another pair of dots here. Yeah, that's one of the exceptions in chemistry. Does that make sense, Tay? Uh-oh. Twitch decided to stop streaming. We hit the limit on Twitch. The API just kicked me off. Oh, that's too funny. Okay. Like, why does it have to go in the XE? That's a good point. Here, let me start streaming again. It's so dumb. Oh my god. Invalid param? Once. Okay, I'm just gonna leave it. You're on the Discord anyway, so it's okay. All right. Okay. Why does it not go in the CL? Good. Okay. If you want the full explanation for why it doesn't, there's a thing called formal charge. Have you gone over formal charge yet, Tay? Not yet. This is my first year. Okay. Formal charge is what yeah, I don't know. They probably have backup systems, Habib, is what they do. I think my PC just got mad at streaming for that long. But if I had a separate streaming PC for that, it would probably be okay. Yeah, okay. So Tay, formal charge is what explains whether atoms are happy with their configuration of bonds and non-bonding electrons. That's what we talk about. Yeah. Yeah. One sec. Twitch decided to kill itself. Still streaming on YouTube and TikTok and the Discord. Okay. Do you know which elements can have more than 4 bars? Yeah. Yeah, if you just want to memorize them. Let me look. Which elements? Is there not like a big list of them? I know nitrogen can do it too. There we go. Someone's done it on Quora. Ugh. I don't really want to go through all those. Okay. Any element from period 3 and below will be able to expand. Oh, okay. So that's actually a lot of things. Oh. Yeah, see? But yeah, I don't want you to have to go into into drawing electron. Yeah, this is no. Yeah, this gets a little bit more complicated. Let me see if someone's got some more pictures at once. Here's a good general rule I'll teach you, Tay. Okay. if you have, for instance, you have too many bars and you need to place things, you are almost never gonna place them on the outside ones. I can say that with like a bit more certainty. You're never really gonna post. You're not gonna put them on here. Okay. You're almost always gonna put them on the central atom. Okay. Or you're gonna have to try to build more bonds. But in general, try to keep these outside things only having 4 bars connected to them. You can load up the center with more. And that's what an expanded octet will do. But anything on the outside, you don't really need to. Dude, I love this. Omega said, perhaps it's considered dangerous to stream about such corrosive substances. I mean, XECL4, not the nicest kid. Love it. That's too good. That's too good. Yeah, you're very welcome, Tay. Yeah. Again, if you have any questions in chemistry coming up on your next exams and whatnot, I stream 3 times a week, Tay. And here's the schedule for it. And also, you get a bond coin for asking a question. You can earn like gift cards and stuff in my Discord for asking questions. So congratulations, you get one of those. But yeah, join us here on the live stream 3 times. We have it 3 times a week. I'm a free chemistry tutor for you if you want. Cool. All right, Twitch decided to break itself. It didn't want us to have a record, but thank you everyone for coming to office hours, for sticking it out with us. It was fun. Thank you, Rampton. I appreciate all your help too.
I really wish that didn't happen.
No problem.
I know.
Dr. Go, what's this $800 gift card thing?
What's this $300 gift card? What do you mean $300 gift card? Who's got a $300?
No, Robux gift card.
Oh, I gave that out. I did that out earlier on the stream. Slimy won it. Slimy won. Good job, Slimes. Yeah, cool. All right, our next stream is on Wednesday. It's going to be an hour later starting than this one, so that's 4 o'clock 4 o'clock Pacific, 6 o'clock Central, 7 o'clock Eastern. Please come by. I'll make a lot of other announcements in the Discord. I don't know why Twitch decided to die on us, but it's okay. It's the main thing is that the people that needed to get help were able to get help. That's all. I don't really care that much about all the Twitch views. Cool. All right. If you want to come play video games with us on actual gaming, let me start that up. I'll play 30 minutes with you guys on It committed suicide. Yeah, I gotta go see it. Okay, that's cool. Yeah, all good. Yeah, but if you guys want to play Fortnite, I will play Fortnite with you guys for at least a half hour. Let me just get that started. All right.
All right. I'm also head out.
Cool.
And then hopefully.
Yeah, hit me up about the OBS. Hit me up about the OBS.
Yeah.
And let's get that figured out. Also, I wanna get your face on the screen for the golden hour, and I think I have a solution for it that won't be so janky and laggy. So.
Okay. Yeah.
We'll just send me a DM or something if you need help with any of the OBS stuff. I'm happy to just like walk you through it and whatnot.
Okay. Yeah. Wait. Is there like some kind of a YouTube video tutorial as well to like go through? Because I feel like I was kind of going trial error.
Okay.
But if there is some kind of a tutorial that goes through the features of OBS, then I don't have to like bother.
No. Please bother me, dude. Because I learned it all through trial and error. That's how I learned it.
Okay.
Okay. I'll try to. You know what to do. You can just type in like starting on OBS and like yeah. For me, I did trial and error. I've been streaming for like 2.5 years now, so like I figured out how to do it. But yeah, let me.
I think that's more like easier way of remembering things.
Yeah.
Long term, but then short term, maybe like just to get started. Sometimes it's almost gotta hold your hand. But yeah, I'll play around with it a little bit as well, especially for like Wednesday and Thursdays. Then I can get on like do stuff on Twitch as well. So then it'd be easier.
Yeah, that would be super cool. Yeah.
All right.
Cool. All right.
Okay. Well, have a good day.
You too. Have a great rest of your Monday.
Everyone
enjoy. We had fun. We'll see if anyone wants to join us with Fortnite. Come to recess. I'll see you guys there. Peace. All right. Too funny. We crashed Twitch. We crashed Twitch today, dude. We crashed Twitch.
Oh, that's what happened. I was like, oh God, what happened? I'm not gonna get my raid.
I know. Yeah, no. Twitch crashed. Everything else streamed
I
though.
thought I had hooked it.
Yeah, my TikTok's still going.
I hope. Okay, so we're playing one game of Fortnite.
We'll play one game of Fortnite. We'll do it.
What? Someone changed it?
All right.
No. Monday is Fortnite. Monday's Fortnite.
Yeah, it's only one game of Fortnite.
Oh well, that's just because I'm over by like an insane amount of time.
Suck